Hi friends, this is my final presentation for GSoC-17 Sonic Anemometer. So the current progress for the project is I have completed the code for single axis TOF determination and I have also completed code for double axis TOF determination. The main task for this project was to find a method to find the time of flight or the time taken by the wave for traveling the distance between transmitter to receiver sensor. So one of the most basic method is the threshold method. Here we set up a threshold voltage and whenever that is crossed first, the time period is taken as TOF. In this method there is a drawback that if a disturbance or noise occurs that causes to cross the threshold voltage, it induces a error in our result. So better method is to find correlation between the waves of transmitter and receiver. So this is the method we have developed during this time. In this method the correlation is found, and correlation is an mathematical operation where similarity between two waves is determined. So whenever the similarity is maximum or the score of correlation is maximum, that denotes or indicates towards the delay that is present in receiver wave. The method for finding TOF is to find the window of samples or the number of samples between the transmitter wave when it started and the maximum correlation value multiplied with the sample rate gives us the time period. So this is the project directory tree. I have created two directories, single axis samples, multi-axis analysis. They have two binary files for PRU0 and PRU1, C file for transferring the data from PRU to host memory. A setup.sh configures the pin inputs for and outputs for PWM, PRODAC and the PRUs. And finally the process.py analyzes the result by taking correlation, program flow, or we can say data flow for the single axis. We set up a clock rate by passing it as an argument to product capture.c. That rate is set up by PRU0 and it generates a clock at that given rate. Now the product capture.c transfers the data from shared memory as shared by PRU1. Now the process.py takes that samples and use NumPy library to find correlation between the waves of TX and RX and then calculates the wind speed along axis. Now this video shows us how to set up the program to find wind speed. We connect the beagle bone to our PC and then attach PRODAC. Sometimes it happens that if we connect the beagle bone after attaching the product, the board doesn't boot up. Now SSH into the beagle bone. Since most of the time we would be requiring super user access, it is better to change the mode to super user initially. Now this is the name of directory where the files exist. Now we have to compile the PRU and C file. For that we pass the command make. Now since the file were already compiled, it shows the message nothing to be done for all. Now we run the script .setup.sh. Now if we have run initially the script after booting BeagleBone, it would create an error if we run it again. Now we attach it another session, tmux session, for sampling data and then run the program by using command product capture. By running the compiled binary of product capture, here 0 and 4 denotes the channel and the 40,000 denotes the frequency of clock rate. Now here we can see it shows 0 bytes per second. It happens if we doesn't install a jumper between the clocks of product. I have referred to it in documentation. Now once the jumper is installed, we can see this way, so we can assume that sampling is working fine. And now we attach another session for running Python program. Now it initially waits for some time for receiving the data from that file productcapture.c, and once it starts receiving it, displays the results in every 2 seconds. Now since the circuit is not complete, as I have referred in documentation, the results are not correct here, but once the circuit is complete with receiver and transmitter functions, the results would be displaying the wind speed. Now the remaining task that needs to be completed is to make a structure for portable anemometer, that is to create circuit to interface sensors to BeagleBone, and that can be portable and could be taken outside the laboratory. The task that can be done is to control the PWM not from productcapture.c but from PRU, that gives us a better control over the waveforms. Now once the previous requirements is completed, that I would be completing them in about 1 or 2 months, since I would be contributing after this period also. I think that if the goals listed here of features are completed, we can assume that our project is at in such a level that it can substitute other options for amateurs or other research projects. First thing I think that can be improved further in this project is to eliminate our dependency from the temperature and humidity values. So that can be eliminated if we find the TOF for the wave traveling from transmitter to receiver and then back from receiver to transmitter. So the challenge here was to how to change the mode of sensors from transmitter to receiver and back then receiver to transmitter. So mainly it involves in-depth knowledge of circuit designing. Okay, and thanks to Beagleboard ORG for such a warm community of mentors and students. I would like to thank my mentors for helping me out during the project, and also to Google for sponsoring such a good program to introduce us to open source world. Thanks again.